This is where the table stands. Well, the nights have just begun. Flying from Syria, and 62, so Mary, I'm your Romeo, I'm got Lilly, I'm your Cherry, I'm your Story, I'm your Birdie, I'm Julia, and platinum gold to any Russian world. Mercury to tell you when it's really cold. Fabio and everything for your tiny ball. Rio, radio, and see you lost a little time. Radio, and I'm by the day. This is Rio on a table. You guys are stable. I love you to help the love you got your best things. Rio, see you, I will juggle you right. To the right,
Hey guys, welcome. We've been working pretty hard to have a pretty good show for you, and I'd like to introduce Lisa. Where's Lisa? Is she in the, Lisa, come up on stage. Yes, this is Lisa Mays, who is the our Wayne Township Education Foundation.
Welcome. We are thrilled. What a wonderful crowd. Thanks for coming out tonight. I'm with the Education Foundation, and Science Claus is one of the outreach programs we're doing in this community. In general, we raise money, and when a teacher does a brilliant idea, which we know is every single day, they come and ask us to help fund it. So tonight, we're able to provide this program thanks to Johnson-Melloh, our presenting sponsor, and the Indianapolis Airport Authority. We also ask you to take a look at your program. Our platinum sponsors are noted at the bottom. So we thank them because things like this would not be possible, especially for free, without their help. So we are really grateful to them for their help. Of course, a super special thanks to Mr. Crosslin. Of you have been to Science Summer Safari. All right. How about parents? Do we have any parents that went when they were kids? Oh my gosh, do we have a couple? So Mr. Crosslin's been doing this forever. It's a summer camp, and we help to provide money to fund that program too, so it's very reasonably priced for kids. So that also is something else we're doing. I also want to thank Keith Ramsey and Guy Hansen. They're helping us out tonight and doing some really awesome science, so thank you to them. And finally, before I close, after the show, we have some crafts for the kids to pick up, and we have cookie decorating for the kids, and we are thinking there might be a special visitor. So the special visitor will stay in here, but we have the other activities going on outside. So welcome. Thank you for joining us. Enjoy the show. Back to you, Mr. Crosslin.
Thank you. Thank you, guys. Thank you again, Wayne Township Education Foundation. So, the idea for this show started many, many years ago. In England, there was a scientist named Michael Faraday. Some of you may have heard of his name, or Faraday. He was known as one of the world's best experimenters. He really liked to do experiments. In fact, because of him and one of his discoveries, the electric dynamo, he found out that if you could move copper wires inside of a magnet, electricity would be transferred out to wires. He said, famously, "I don't know what they'll use this for in the future, but I do know the government will tax it." And every time we get our electric bill, you can thank Michael Faraday. Now, I like Michael Faraday for another reason. I got a chance to go to London to the Royal Institute, one of the longest science groups in the world. In the Royal Institute, Michael Faraday was the scientist there, and he had a brilliant idea. He did the first public science show for children in 1825. Up until then, science was for the rich, the kings, and only the people, special people, did science. Michael Faraday, like myself, thinks that science should be for everyone, including all the children are here. So he is my hero, and his first Christmas lecture in 1825, believe it or not, was on the chemical history of the candle. He did 6 lectures on this topic. As a matter of fact, if you see the candle burning there, he said that if you studied the candle, you can learn all the science in the world you'd ever need to know. The different colors of the flame, different temperatures, the wax, how water comes out of combustion, how water is formed, how it's a chemical reaction, how gravity makes things fall down, but through convection currents, wax goes up. So you can go watch the other 6 hours of video. They're online about Michael Faraday. So today we're going to learn a little bit of science, and I have a candle here in honor of Michael Faraday. See, he believed in observation. And so if anybody would like to give me an observation, what do you see in front of you? If I can get this to light. What do you see? Anybody? You see a flame. An observation would be, it's white, it's cylindrical, it's giving off light. But if you look closely, some of you may say it's a candle in a candle holder, right? But I'm here tonight for you to make good observations, because what you see may not be what's going on. So, I'd like to start the show. What? What? Let's get on with the show. Let's invite out our guests here. Come on out. Where's my other scientist here? Let's give a round of applause for Guy Hansen. Guy, retired Lilly scientist who's responsible for going around central Indiana and farther doing chemistry as a blast. Any teacher here, see him after the show? Why, Guy? What can you do for them?
Come into your school and get kids excited about science, doing some really cool science, just like you're going to see tonight.
Thank you. One more time for Guy. Eli and Lilly. Chemistry is a blast. My friend here, Keith Ramsey, 6th grade science teacher extraordinaire, Bridgeport. You can join him on Ramseyland. Where do we find Ramseyland?
YouTube and Instagram.
YouTube and Instagram. So these are our team here. We got a few rules for tonight. We don't want anybody hurt. Our first rule is you need to smile and nod at us. I don't care if you learn anything, but make us feel good. Try it right now. Everybody smile and nod. Smile and nod at Guy. Smile and nod at Keith. Smile and nod at your parents for bringing you. Okay, that's rule number 1. A lot of smiling and nodding. Rule number 2, there might be some loud noises. In fact, these two guys are going to make a loud noise. We'll try to warn you. If there's loud noises, put your hands over your ears, all right? And more importantly, the most important rule, if this happens during the show, if you see this, you see a dinosaur, run, please run. The doors are that way. Okay, let's get started. All right, thanks, guys. Okay, So we have almost all these activities that you're going to see today happen in Wayne Township classrooms with great teachers from kindergarten all the way up. And we study motion in 2nd grade all the way to 5th grade. We talk about Sir Isaac Newton, who came up with 3 laws about the world. Now, I'll tell you about a law. A law has to be something that happens here, happens at your school, happens at your home. There's not a lot of science laws because they have to happen everywhere. I hate this part. There's a lot of parts I hate in this show. So one of his laws that he came up with when he studied principles of mathematics and motion was an object has an action and reaction. I've given this some what's called potential energy. On the count of 3, you guys say kinetic energy. We'll see what happens. 1, 2, 3. This is going to be a great night. You guys clap that hard for a balloon wave. All right, so our next he had another law that says object at rest stays at rest until another force acts upon them. So I need a big dad, and a small kid. Here's a big dad, and a small kid. All right, give them a round of applause, guys. Watch out. All right, so Dad, you're right. These are called grandpa skateboards. You should not get hurt on them. I'm a grandpa, so sit down on this. Cross your legs so you're all the way on it. So right now you're an object at rest. Come here, my dear. You're another object at rest. Have a seat right there. Wow. So he put wheels. Wheels is a simple machine that helps make work easier. So all you have to do is pull your dad to you, okay? And do you have any money with you, sir? Because I'm broke. You have $5? Let me have it here. We'll just hold your wallet. How about just hold your wallet? Thank you, that's even better. All right, all you gotta do, wait a second. All you gotta do is pull your dad to the middle and you get to keep his wallet. Ready? Go. Pull your dad. No. Wait. Isaac Newton said you should be able to do this. You have inertia. Just pull your dad to the middle. Oh, wait a minute. Wait a minute. There was a variable, a control variable in this experiment. Let's try it again. You know, I'll tell you what. We'll let your dad do the pulling this time. Okay, you hold on tight. Hold on tight. Right there, this. Right, no, this part. Hold it right here, sweetie. Okay, just pull yourself to the middle. Pull yourself to the middle. This is not working. Why aren't you pulling? Wait a minute. Maybe Isaac Newton was wrong. I think both of you have mass. Who has the most mass? Point to him. More mass. And so we can't overcome his inertia. I think I have a deal we can do. What if we add more mass to you? Say yes. This goes better if you say all right, here we go. I'm a lot of mass. All right. Now let's see what happens. Go ahead and grab this and pull your dad. Let's give a round of applause. Good job. I'll let you fight over this. Let me help you out. Let's move these out of the way here. Take them off the side there. Thank you. So that is just one way we try to show kids these laws of motion. We get the elves and we move these all the way back. Now, where's Mr. Hansen? You're my catch guy over there. This is going to be a loud noise. So, we have here an object at rest. We want to give it some action or reaction. It's filled with carbon dioxide. I'm going to sit on and push a lever. The gas is going to go out. That gas is going to push everywhere on that canister. It's going to push up. It's going to push to the side. The only thing I have to worry about is the one that's going to be pushing out. When it goes out, I should go this way, I hope. We tried this once. Here we go, ready?
Hansen. 3, 2, 1, go! The Hansen.
That was good. What's next? Okay. Let me check what's next. What's our next slide? You see it. I think we're going to do something. Let's see. Yes. Mr. Ramsey's going to come on stage. He's going to do some chemical reactions. But I'm not too good at chemical reactions. This is a physical reaction. Everybody say physical reaction. It's still physical. Still paper, still physical. This is physical. This is it's still paper. A physical change is when the matter stays the same. It just may change its form. It may melt. It may turn to a solid. It may turn to a gas, but it's still paper. Now I do one. Let's try this guy right here. These are kind of dangerous. They're cannonballs. As long as I don't drop them, we'll be okay. So this is Devin, our intern from WFYI. Let's give him a round of applause. Devin, here you go. Sorry, Devin. Don't drop it. If you drop it more than twice in one show, this cannonball could explode. I see you're fearless, sir.
Yeah.
Good.
You're right.
So here is some action. This is mechanical energy. You should hear sound energy. Did you hear that?
Yeah.
So mechanical transfers to sound. But if you take a rusted ball, and you add aluminum, this is pretty cool. I hope this works. I hope I don't get hurt.
Me too.
Ready? See if it works. I hate doing this part. Ready? Here we go. Give me a 1, 2, 3.
1, 2, 3.
It worked. It works. It still works. Hey, come here. You try it. You try it. Let's give her a round of applause. Now hold it like that.
Okay.
Don't drop it. Don't hurt me.
Don't hurt you?
Yeah, it's a glancing blow. Watch your nails.
Okay.
You have insurance.
Yes.
Okay, good. A glancing blow. Whoa! You need a 1, 2, 3, everybody.
1, 2, 3.
Yeah. Let's give a round of applause. Here's a rule about performing. If it happens once, don't do it twice. Good job. Okay. So we talked about magic and science. What you're going to see next is not magic. Hey, there's magic in Christmas, but we're going to do some science. So I'm going to try something here. I don't know if this is going to work. What do you see? Okay, let's see. Okay, let's try. Hey, help me out here, Mr. Ramsey. Let's see, I'm having some trouble with my shaving cream.
You got it, shake.
There we go. Let's see. Go ahead, help me out. You guys see anything? Anything? What are we seeing here? Try it again, guy. Are we getting it right? Don't film this for a second. Film them on this one, okay?
a face.
What was your face? What's up with it?
I love Genie.
You guys see anything? I don't know. Let's give Keith a round of applause. Keith.
We want to show you a chemical change next. It was back in 1965 when NBC released their sitcom, I Dream of Jeannie. And the director wanted a cloud of smoke behind which a genie would appear. But he didn't want the actors coughing on stage. He didn't want the AV equipment to be damaged. And so his special effects crew came up with this decomposition exothermic reaction that would release a cloud of white oxygen behind which the genie would appear that would be safe for the actors to breathe. And so we want to recreate that same chemical reaction with you today. So we need 6 volunteers.
Oh, now I have to pick. Let's have somebody from the back. Yes, come on down. If I give you goggles, go up that way. Elves, help them up on stage, please. Go that way, guys. This way, elf. No, take them at the bar corner. No, not that way. This way. All the way to the end. There you go.
While he finds those brave volunteers, a little backstory on the special effects of this experiment. The special effects crew used a molecule called hydrogen peroxide. Raise your hand if you've used hydrogen peroxide. Those moms out there who've cleaned cuts before. The chemical equation is H2O2, which sounds a lot like water. H2O. But the difference is there's an extra oxygen atom. And it makes all the difference. If you left hydrogen peroxide uncapped within about 6 months, it would be cold.
Don't put them on. When we have kids, help them get them up to picnic.
But today we want to speed up the rate of that reaction. And so we're going to add packets.
You guys come stand over here. Come stand
So
over here.
that extra oxygen atom will be released all at once in a cloud of white oxygen. And so our volunteers here, they're going to drop just a packet of manganese dioxide to catalyze the mixture and release our genies. And we need your help. So at the count of 3, you're going to say, I dream of Jeannie. Practice that. 3, 2, 1. And when you say that, at once, they're going to drop that packet of MnO4 and release the genies. Now make sure at the count of 3 you say, I dream of Jeannie. Or you might be on Science Claus 1. So we're going to give you guys the packets. One here. At each one, and you're just going to take a knee like this. You're all you have to do. When they say, I dream of Jeannie, you're just going to drop it. Okay? So here's the words. And just take a knee right here. Now, when you drop it, you're just going to take one step back.
Get out on one knee, please.
Take a knee. Put it. That's perfect. And when they say, I dream of Jeannie, you're just going to drop it in. Okay? You ready?
Not yet. Not yet.
Not yet. Okay. You're doing great. And you're just going to drop it in there. Now, when you drop it, you're just going to take one step back. You ready? Now, when they say, I dream of Jeannie, you're just going to drop it in Yep, and you're just gonna take one step back.
So I don't go.
Not yet. Wait, when you say it, you'll tell him. We'll help you.
Just like this.
Are you guys ready and nervous?
Yes.
What are you going to wish on? What are you going to wish on if a genie comes out?
Maybe one.
Okay, so when the audience says, I dream of Genie, we're gonna drop them all at once. You ready? All right, audience, are you ready?
Yeah.
Okay, 3, 2, 1. Oh, look at all those genies! Oh, genies everywhere! Give your volunteers a hand.
Good job. Yeah, there we go. I did go to your school. Hey, thanks, Keith. I need like a really, do you have a brother and sister, like a big brother and a small sister? I mean, a big brother and a small, okay, so yeah. Jonathan, bring your little sister. There we go. There we go. I got it right here. Come on, Jonathan. Okay, so one of the things we do in third grade, guys, go this way. Elves, help me get them up and down the side there. There we go. Go ahead, Pete. What school do you go to?
Chapel Glen Elementary.
Chapel Glen. Okay, you look pretty strong and big. Let's see those muscles. Yeah, let's give it for the big strong guy. Come on here. You're going to be epic, okay? And what school do you go to?
Chapel Glen.
Chapel Glen. 6th grade or 5th?
Kindergarten.
Oh, kindergarten. I hate to say this, you're going to be the load today, okay, Cinderella? Okay. So we got a brother and sister team here. Come on over here, brother. Sister right here. In 3rd grade, we teach about simple machines. Okay? Why don't you guys have a seat on the stairs right there? Thanks. A simple machine, we learned that simple machines don't make less work, they make work easier. Thank you. They make work easier over a longer distance or time. So this is going to be real simple. We're going to let you shoot your sister up and the elf will catch you. Okay? Okay. Okay. John, down here, buddy. Down here. Sit down on your knees. This is a lever. It has 2 parts. Everybody say the bar. The fulcrum. The fulcrum. Do it with me. You know it. The fulcrum and the bar makes a lever. Okay, so all you got to do is we're going to shoot her up. Come here. You look so nice. Stand on here. Okay, both feet. Put your hand over your head, because if you hit the ceiling, I don't want to hurt yourself, okay? Are you brave? If she goes in the audience, will you catch her? Yeah. You promise? Yeah. Are you nervous? All right, on the count of 3, you push, it's your sister, it's okay. You push down as hard as you can, we'll send her up. Ready? Everybody. 1, 2, go! Look, on 3, you push down. No, on 3, you push down as hard as you can. Let's try it again. 1, 2, 3. Dude, this is embarrassing. You're ruining the show. Well, maybe we should move the fulcrum, right? Yeah. Okay, so, switch sides, switch sides, switch sides. Let's move the fulcrum. Ready? 1, 2, 3, push! Stop, stop, stop. You're embarrassing yourself in front of everybody. Step down, step down. You know, I'm sorry, Mr. Dooley. This is so, I'm sorry. Well, let's show them how we use science to do this, okay? Okay? Man, all right, stand up. Stand on that, face, I know it's hard to face them after you couldn't do it, but stand on this. Put your hand on my shoulder. Do you believe in science? Yes, say yes, I do. Okay, take one hand and see if you can push down and lift your brother up. 1, 2, 3. Whoa! side. 1, 2, 3, push. Wow! I don't know what to say to you. I don't know what to say to you. All right, let's give her a round of applause and a round of applause. Let's head out that way, guys, off to the side there. Oh man, what's next, guys? What's next, Keith? Oh no, I hate this one. The guy really needs you. I haven't done this one for a long time. I've been trying to learn my science. There's something about pressure. And so I promised you guys a bed of nails demonstration. I went to India and this is the bed of nail they gave me. I don't know if this is the one I should use though. So we'll do a little experiment. Here is a bed of nails. Here is an object with mass. So, this has so much mass, and this has so little surface area, all the force will be focused here. That's pressure.
Yeah.
All right, let's see what happens. Ready? 3, 2, 1. I don't know if we... Should we do this bed of nails thing? With me? Well, I have any friends in the house, okay. I have one request. If we do a bed of nails, I need a lot more nails. Let's see this bed of nails. Guys, see, move that off this side. Good.
All right, let's
Lift it up.
Here we go.
Should I do it? No. Yes? Okay. All right. I'll do this for science. Okay. You guys got to help me down then, okay?
Okay.
So you on one side?
On each side?
Ouch! Ouch! You got me? I hate this part.
This is the hard part.
Don't let go. I know what you want.
Exactly. Got it. We got you.
I'm gonna quit. Okay, never mind. Ow! Oh. That kind of hurts. Look, let's be concerned with the kids. Let me see this shield here, okay?
Okay.
It's even worse. Wait, what? What are you doing? No! Yes or no? Are you done? More, no, more. Okay. Thanks a lot. Are you done yet? More? Okay, one more. I hate this part. No. Yes or no? Okay. Turn it sideways. Turn it sideways. The other way. Turn it so that flat.
There you go.
Thanks a lot. Safety, guys. You guys put safety on. Wait, I need that, not you. What are you going to do? What is he doing? Okay. Did you get it?
Are you still alive?
Help me up. 1, 2, 3. Why did you say yes? spread over all those nails. Now don't try this at home. But it also worked because the more mass they put on me, the more it was absorbed in the initial blow. So I'm going to take a break. Everybody give me a round of applause. Thank you. And who's next? Guy, you're up.
I can answer him.
Yep. You did.
You want front and center?
In the center.
Yeah.
Very good. Okay, so I need everybody to look up at the ceiling and blow as hard as you can. Yeah, so what you blew out obviously is a gas. Can somebody tell me what the name of that gas is? Air. What did we blow out? Oxygen we breathe in. I heard it. Carbon dioxide. Carbon dioxide's a gas. It turns into a solid. Does anybody know what this is? Very good. It's made out of carbon dioxide. If you squeeze and freeze carbon dioxide, the same gas we breathe out all the time, it turns into a solid. Now carbon dioxide is very, very cold. That's why I'm wearing these special gloves to hold this. These are called cryogenic gloves. Not because they make me cry, but the word cryo means cold. So it's like saying cold gloves. In fact, this is so cold. If I took this glove off and I took this one pellet of dry ice and I put it in this hand with no glove and I squeezed it very tight and I held it for this long and I went to take it out of my hand, it could peel the skin right off my hand. It's that cold. Well, let's do an experiment with dry ice. Now we know that things exist in one of three ways. They're either a gas, a solid, or a what? A liquid. And in this experiment, we're going to use all three. We're going to use a gas that's been super frozen and squeezed to a solid, dry ice. So I'm going to take 3 handfuls. Actually, I'll take 4. 1, 2, 3, 4. More? Let's do 6. 5, 6. More? Should we use all of this? All right, let's get a bunch of dry ice. Okay, actually that's just right. And so now we have a bunch of dry ice. And we need one more thing for this experiment. Let me get this. It's backstage. Okay, so we have some boiling hot water. And in a moment, we're going to do an experiment with these. But before we do, I have to warn you. Everybody that's sitting in the first 3 rows, you're going to have to do something very difficult. You're going to have to stay seated right where you're at. I mean, you're going to want to get up and move so bad. You've got to stay seated where you're at. All right, what I need from you is a 5, 4, 3, 2, 1 countdown. Ready? 5, 4, 3, 2, 1.
you see, oh no, it's not toxic. That gas that you see coming out there contains two things. And you know what both of them are? What's one of them? Carbon dioxide. What's the other thing? Water, that's right. We took very hot, boiling water and poured it on very cold, dry ice. How many think this is cold? How many think this is hot? How many think the cold and the hot canceled each other out and it's room temperature? That's a good guess. This is actually very, very cold. And the reason is that dry ice has a lot more energy in it than the water, even when the water is boiling hot. So a solid, a liquid, and a gas working together to give us a very cold reaction. Cool. Yeah. All right. You want this back?
Yeah, take that. Thanks, guys.
Oh, wait, watch that. And back over here.
Some of you may remember some of these from last year. I really like to do things with sound and sound energy. Sounds like there's a lot of sound energy in the room. That's good. That's good. So the first scientist who studied sound was a man by the name of Aristotle. And he concluded that sound is like a pressure wave. We're coming back to pressure. And so let's see, I need a volunteer. Come on up. Are you a volunteer? Come on up. Yeah, be careful coming up. There you go. Help me out here, all right? You got this right here. Back down that way. Hold it tight. You got it in two hands. So sound travels through waves or pressure waves. You can see it sometimes. Sometimes you can see it when your windows rattle after lightning. You hear a big thunderclap? You might see the lightning and then your windows rattle. So let's say this is the air and this sound energy. If I hold it tight, you got it? 1, 2, 3. Let's see how sound travels. That's pretty cool. 1, 2, 3. Why don't you, let's see if you can, let's see. This represents the air. You take your hand and let's give it a big hit. Wonder what would happen if two sound waves met in the middle. One day, two sound waves, one on the beach, met in the middle. Ready? We'll do it together. 1, 2, 3. Cool. So you can see sound waves. Mr. Montgomery is showing us a video up here. This is a low 1 megahertz. And if I go faster, now you might see more waves. And jump to the middle, this might even get worse. Go ahead and let's hear it, that one, Mark. I can't do that that quick. Let's give him a round of applause. Thanks. Be careful. I do know, science is also about animals. And so I always like to bring an animal to the show. And so today's animal, you have to be really gentle with my animal. It's not fake. That kind of talk makes him so upset. No. It's a science chicken. Science chicken, yeah. Who knows how to chicken? Who's like a chicken? Come on. So how does the chicken move? Show me. Like that? What does his head do? Like this? Come on, start flapping. One more time. Maybe not such a good chicken. Let's do a buck wings too and head too. Ready? Not bad. Here, let's see you try it now. Sound is vibration. We teach that in 3rd grade. You hold that, squeeze it on there, squeeze it tight and pull it down. Pull. That's rude. Try it again. Up here at the top. Not so tight this time. Go ahead. Oh, that's better. Still kind of rude. Let's try it one more time. Go ching, ching, ching like that, right? Not bad. Let's give a round of applause. Hey, take a bow, take a bow. All right, get out of here. So, I thought we'd try something a little different, a little dangerous. In 1905, there was a scientist by the name of Henrik Rubin. And Henrik Rubin invented the Rubin tube. So let's see if this will work. I'll need some help here. All right, so to get this to work, we need gas. You got the fire extinguisher? Let's turn that on a little bit there, Keith. Go ahead. So Heinrich Rubin that's probably good. Let's move this a little bit closer. Let's turn, okay, here we go, ready? Let's go right here. Hold that. Turn that down just a little bit. So, on my phone here, I have an app that is a tone generator. What I hope to do is hook this up to here. Keith, I'll let you do that. And let's see if we can see what Mr. Rubin saw years ago. We got this turned on? Is it coming through there? It's on?
Yeah.
Yep. Let's try something a little bit different. No hole in there. This is filled with gas. Let's try one more. That's better. We'll move over to the side just a little, Devin. Every time the sound goes through there, and you see the different sounds on it? Let's try it here. Let's try one more song.
Hello, I'm Johnny Cash.
Probably not Johnny Cash. We'll try one more time with the sound generator. Sometimes these work, sometimes they don't. We won't give up. We'll try one more time. You ready? Well, give me a round of applause. We tried anyway. Thank you, guys. All right, who's next? Yeah, you up, buddy? There we go. Let's move that off the stage. Thanks a lot. What's next on this, okay? So, we thought we might try some things with some air, because air is made of matter. You seen these before? Oh, that's how they work. Kind of. Let's see. But this one's too small. We have another one, I think. try this guy right here. That's what we need. You see, air is made of matter. And right here, this is an atmosphere bar. What this means is this is 14 pounds. And here in Ben Davis, we are 751 feet above sea level. But what this means is right now, there's a little bit less than 14 pounds pushing on every part of your body. That's called air pressure. Air pressure. And we'll do an experiment. I need a volunteer. JC, thanks for volunteering. Takes courage. Go ahead. So, this is JC. He goes to Maplewood, 6th grade. You don't say anything? Okay. So, put your hand out. So, this is 16 pounds that you feel on you. Now, the reason he doesn't feel it down is because he also has 16 pounds pushing up, pushing everywhere. Now, I like to say, like, this is normal pressure. This is normal pressure, all right? Sometimes we have weather. This is high pressure, okay? High pressure, normal pressure. Low pressure, I don't know. I like high pressure. So we're going to try an experiment. We're going to try to take all the air out from around JC and see what happens. See right there. Let's see. We need to bring up the shop back up this way, okay? There we go. All right. Go ahead and stand in there. Thank you. Thank you. Okay, so right now he has 14 pounds of pressure all over him. Let me see. We have a vacuum. Now the vacuum works because it pushes the air out and the rest of the air in this auditorium pushes towards this thing. Okay? It pushes out, the rest of the atmosphere pushes in. So here's what you're going to do. Hold that. You got it? When I turn that on, it might suck your shirt. Let's practice. Try it. Try not to do this. Okay? That's a problem. Turn it off, please. Now, can you move your arms? Show us, move your arms. Move your legs. Not bad. Let's see what happens when we take all the pressure out, all the air out. Now it's probably going to get sucked in there, so try to keep that, put your fingers around the bottom of it, the bottom hose. There you go. Turn it on. Are you scared? You should be. Move your hand away from it. There you go. Pull it away from you. Put it by your, don't let, put your hand down by it. Okay, stop for a second. You got to cover the front of it, okay? Put your hand on the front of the hose. Got it? Got it? Try again. Turn it on. Here we go. Let it go through the... I'll tell you what, stop for a second. Stop for a second. We'll pull the air out of me, all right? Step down. I hate this part. Pull it on up. Help me out here, JC. I hate this part. This better not do what I think it's going to do. Okay, JC, are you ready? I hate this part. Okay, turn it on. I hope my butt's not showing. Okay, so now all that air is taken out of there and I can't move my legs because of 14 pounds per square inch. Do you mind turning this off? Oh, thanks. Give me at least a round of applause for that one. Thanks, Casey. Get out of here, Casey. There's a lot of ways to show this, and this is a famous one that we're going to try. Except I need a milk carton. I need something to burn. I need an egg. Anybody have a boiled egg? Boiled egg. This lady in the front, do you have a boiled egg? Would you come up on stage, please? Bring your eggs. You brought boiled eggs to my science show?
Yeah.
Would somebody help her up, please? Science is for everyone.
There we go. One more time through the corn.
And the air pressure, what's your name? Oh, you look familiar.
I'm Priscilla.
Priscilla.
Uh-huh.
This is not Priscilla. This is my favorite mother-in-law in the world, Roberta. Let's give her a round of applause. And I always say it, she's my favorite mother-in-law, and what do you say?
You're my favorite son-in-law.
I'm her favorite son-in-law. I'm the only one. Let me see. Okay, so she brought me a hard-boiled egg to do this experiment.
Are you sure it's hard? It isn't.
I asked for hard-boiled eggs, and you brought me this one?
Well, here, try this one.
Thank you.
It worked.
You sure? Don't? Yes? They're saying no. Okay. Luckily. How do we peel these? You just peel them?
Yeah, the best way you can.
Best way you can. All right. So, Roberta's done a lot of science projects with me. Some of them willingly. Okay, you hold this. We'll put that one away. When I say so, put it right over there. Let's put it over there to practice. Wait a minute, don't push it. Does it fit?
No.
Wait a minute, it doesn't fit. Well, we'll try it anyway. Here, let's put that away. When I say so, just set it on there, okay?
Okay.
Have you done these before?
No.
No?
I've boiled eggs before.
You got it? Okay. We probably should have her some goggles, Guy. You got some goggles for her? I'll be in trouble if we hurt Grandma. There we go.
Yeah.
Got some goggles for you, okay?
Oh, okay. Oh, thank you.
Grandma Scientist, give her a round of applause. All right, here we go. I'm gonna burn this. I'm gonna light this, put it in there. It's gonna start burning up the oxygen, and it should take all the air, and the sky should push that egg in. So you wait till I go like that, and we'll do it, all right? Here we go. Here we go. Wait. Here we go. Wait. Okay, now. Put it on there, Move back.
Don't work.
Don't be so negative.
Oh, it works.
Not yet. You know what?
You want a Kleenex? Here.
Another genie in the bottle. We'll try one more time. I didn't get it burning good enough, did I? Put it down this way. We'll try it one more time, Roberta. Let's see what happens. Don't eat it. Let's see what happens. Let's really get it going. Ready? Now, put it on there. There we go. Let go.
It just stopped again.
Just stopped again?
Yeah, I think it just has that oxygen.
It's too big of an egg.
You brought the egg up.
It needs oxygen.
It needs oxygen, huh?
There it goes.
There we go. Hey, a little bit. I'm helping. Let's give Roberta a round of applause. It's my fault. Thank you anyway. I suppose you want that egg.
It's an egg.
Here you go, Elf. Thank you. Well, we're doing okay. Let's try something else. Let's try this guy right here. This is a giant smoke ring machine. If we can see the air pressure of this, it might be kind of cool. Let's see if we can. Ready? Add a little smoke to it. Mr. Ramsey, are you here? Can you help me pull this up? There we go. Okay. You can still use it. Let's see if this works. Hopefully it will. So this has some air pressure. Oh. That's pretty cool. Stay seated, stay seated. Smoke machine. One. So, there's a guy. There was a guy by the name of Bernoulli, and he studied how gases flew and would move. And he said that when you increase the flow, it decreases the pressure. And maybe we can get the rest of this air to help us with this. So let's see what happens when I do this. Close your ears, it's loud. There's only one thing better than one, and that is two of these. Where are you? Mr. Ramsey, Mr. Hansen, come on. Join me on stage. Where are you? Grab those two. Grab those two. We're going to have dueling toilet paper wars. You're on this side. You're on that side. Let's hear it for Hansen. Over here. Come to the middle. You guys come to the middle. Come to the middle. Back to back. Back to back. 8. Let's go 7 paces and turn around and fire. Do you know how to turn it on? Oh yeah. There's a special switch. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8. That was worth a lot of applause. We have the start of our grand finale. So you guys some more. You guys go back. We got 2 more. Thank you, Elf. You want to grab that blower too? Thanks. We could not do this without the elves. Thanks, buddy. You want to get closer? You're good.
That's good. That's good. Okay, we want to do another chemical reaction. This is an exothermic decomposition reaction, and we need 3 brave volunteers.
Who's gone to my summer camp? There you go. We got.
That's it. Okay, buddy. You're going to be right here in the middle. Now, all you have to do for this is just
Hurry.
this
Oh, we got.
into this.
We got this guy. We'll get you the next one, okay?
Okay. Okay, now all there is to this is just going to pour this.
Don't do anything unless he tells you.
Okay? That's all there is to it, all right? Okay, so we want to do this one at a time. This is called Old Foamy. And what we're going to do is, again, we're going to release oxygen, and that oxygen is going to get trapped in bubbles. Hopefully a lot of bubbles. So for our first one, what's your name? We have our very brave scientist here, and he's going to pour this flask into the second one, and we're going to count down 3, 2, 1. You ready? All right, 3, 2, 1. All of it in. All of it in.
Quick, move.
That's so weird. Oh, can you touch it?
This makes me really
Go
fast.
all the way up.
Nice job.
That's so cool.
It is Faraday. Is this one the same, sir? Is this one the same?
Oh yeah, this is exactly the same. Not changing anything. All right.
Here we go.
All right, 3, 2, 1. 3, 2, 1.
More quick and move. Now move.
Wait, what? It turned into baking soda. Oh, I can
Keith, why is that called exothermic?
It releases heat and steam.
It's going on my...
Wait.
Okay, you did great. Thanks. All right, you ready? So, okay. All right, we're gonna count to 3. 3, 2, 1.
More quick and I'll boom back up.
That scared me.
Oh no.
Oh, God.
Let's give a round of applause. Stand up. It's hot. No, it's too hot. It is exothermic, which means what, Keith?
It releases heat.
Don't touch it too hot. Let's give him a round of applause. Thanks, guys. Well done.
It didn't shoot us as far as
This guy out of the way.
Alrighty. Table. Excellent. And we just put it right here. Great.
Okay, we need 6 volunteers. Volunteers.
How many do we have? 4. Hold on, let me see how many we have. How many do we have?
Here you go. Seeing a lot of gases. Okay, a lot of gases. And gases, they behave differently, or they have different properties. And we're going to look, these balloons are filled with different gases. And the hard thing about gases is they're very difficult to tell apart. Somebody tell me the name of a gas. Any gas. Yes.
Hydrogen.
What do we breathe in?
Oxygen.
Oxygen. And what did you say? Hydrogen. What do we breathe out?
Excuse me? Dirty air.
Which is carbon dioxide. So there's a lot of different types of gases, but they're hard to tell apart. So if I have a handful of carbon dioxide and a handful of hydrogen, I can't tell them apart. I can't see them. I can't feel them. I can't smell them. I can't taste them. I wouldn't want to. I can't hear them. I can't tell them apart. So one way that we use to tell gases apart is a flame test. A flame test. And that's what we're going to do with these balloons. We're going to try to determine what gases are in these balloons by doing a flame test. So if everybody can take one step back, just one, perfect, perfect. Okay, so this is where we need your help. What I need you to do is yell out to me. I'll point to you and you tell me a color of one of these balloons. What color do you pick? Red. Okay, who has red? All right, what's your first name? Allie. All right, I'm going to light this candle, and I want you to hold this real tight with both hands and touch the side of that balloon, okay? But before you do, give me a chance to run, okay? No, I'm not going to run. I'll stay right here with you. All right, Allie. This is the hardest part. There we go. Hold that real tight, both hands. Touch the side of that balloon, go right up to it. What's our next color? Which one? Which color? Green. Green.
All right, what was that?
See that those balloons, they behave differently. One gives us a pop. The green one gave us a pop, not out of the air. The red one gave us a fireball. Fireball. Can somebody tell me what gas gave us the fireball? Very good, very good. How many have ever seen a blimp up in the sky? Yeah, they used to fill blimps with hydrogen. Can you believe that? One little match, and that whole blimp would go up. So now they fill them with the gas that gave us the pop. What is that gas? Helium. Very good. All right, what's our next color? Green. Okay. We're ready.
I'm gonna go wet. I already know what's coming up.
You know what's coming up, don't you? Hold that real tight. Touch the side of that balloon. Go right up to it. what's our next color? Okay. What's the next color? Pink. What color? So what's our next color? Now this is very interesting. We only have one pink balloon up here, and it's the first balloon. And this is very interesting to me, because a lot of times people pick that first balloon. But this is a very special balloon. How many think this balloon is filled with helium with a pop? How many think it's filled with hydrogen with a fireball? How many think this balloon is filled with whipped cream? Well, you guys are going to find out.
It better be.
Right.
It better be whipped cream.
Let's hear it for our volunteers.
We're ready for our grand finale. You guys have to stay, you boys move back a little bit, please. We're going to do 4 grand finales. I don't know what you call that, but we're going to do 4 of them. Where is Keith and Guy? Come on out. So, Guy, you can have one of those. We put some fuel in this, some very flammable fuel. In fact, we put jet fuel in them. Listen up, guys, have a seat. Boys, have a seat. And the thing is, this fuel will not light because it's a liquid. So what we've done is we've atomized it. Just like in your car engine, it's not the liquid fuel that ignites, it's when it mixes with air. So just to show you that there is no liquid in here, we're going to pour it out. I'll do mine first. This is called the whoosh bottle. And it only works if you have a Lego sword. So, let's see. Any of you kids have a cigarette lighter? I always ask. Okay, so, all right, can we turn the lights out, Mr. Montgomery? A little bit, not all of them. This is called a whoosh bottle for a good reason. Let's see if it works. Sometimes it does. Here we go. Yeah, look what's left over. That's water. That is the water that's left over from combustion, just like Michael Faraday said. So when you see a jet going through the sky as it's burning its fuel, the water drops are coming out, condensing in the contrails. You want to try it again? Let's try it again. I lost my sword. So you got your lighter? You got your lighter, okay.
You want a extender?
Yeah.
There you go.
Now you got the airplane.
Good, all righty. Cool.
So these guys can see it?
Ready.
Put a little bit closer to the glass.
Yeah, I will.
Put that one on pretty good.
Okay, are we ready? All right, here we go. Whoop. Ah. There we go.
Now you'll see it too, help us. Okay. We're ready for the grand finale, are you? We need some help. So everybody go, ho, ho, ho. Good. A little bit louder. Good? Ping pong ball. How you doing, Santa? I'm good. Oh, 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 oh. So. Okay, for this to work, this is illegal in 34 states.
35 in a moment.
35 after this one. Guy, you wanna do the pour? Okay. Guy brought some dry ice. That was pretty cold, huh?
Pretty cold.
How cold was it?
70 below.
He brought some 70 below dry ice. Keith brought some liquid nitrogen.
300.
320 below. So if we do this right, we're going to fill this container with some liquid nitrogen. Not a problem. Yes. So this is going to be a loud boom. Thank you. Can you go down more? Keep going. You good. I go down, you go up. How much?
That feels about right.
Oh, it's it's more. You know what it's doing? It's bubbling, not going down the.
Yeah, not going down. That's good. That's enough. That's enough. There you go.
So, no problem. This liquid nitrogen, which is, there's a good amount, about that much. As a liquid, it's that much. But it is turning into a vapor. Our atmosphere is filled with nitrogen, 70%. It's an inert
Gas.
Inert gas. Doesn't hurt us. It's every breath you take. The problem is, all night long is pressure. So long as I don't put a lid on this, we'll be okay. But we're going to put a lid on it. We're going to put a lid on it. We're going to drop it down. He's going to put ping pong balls in there. Let's see what happens. Let's move this back. Okay, are we good?
Yeah, put on
Here we go.
7
Santa, where's Santa? Afterwards, Santa will be out there telling their parents who's been good and who's been bad.
They know.
They know. They know. Okay, cover your ears. Here we go. Cover your ears. Cover your ears.